Welcome. So today I want to talk to you about fluid math skills. So what are fluid math skills? Now, if you take any math problem, there are a couple of things that you need to think about before you can start the whole thing. One is what's going to be your approach. Now, the reason for this is because most math problems have multiple approaches, different ways of solving the same math problem. The second thing you need to think about is your solving skill. Like how well can you solve should you take a particular approach? So this is where your execution begins. And the third one is basically your accuracy or your probability of errors. So your solving skill will indicate the ease with which you can do it, the speed with which you can do it, the familiarity that you have. The errors will tell you how accurate you can be, how well can you prevent the entire error that can emanate from a problem. In order to explain this better, let's take a couple of examples. So the first one is I want you to try and solve this problem, and if possible, measure yourself on how long it takes you. So the problem is 8 times 9 times 10 times 11 times 12. Okay, what is the answer to this particular question? So let's see if I can reduce this slightly. Yeah. Okay, so how would you go about solving it? Because there are so many different approaches to it. And the second one is how would you go about solving the same thing for 3 times, 4 times, 5 times, 6 times, 7? Okay, now they're very, very similar because we're talking about multiplying 5 consecutive numbers. However, the approach need not be the same for both problems. It could be different based on your solving abilities and your level of accuracy in terms of doing this. So let's try and solve these problems and let me show you the different ways in which one could actually go about doing it. So the first thing is, let's take 3 times, 4 times, 5 times, 6 times, 7. So this, you could just follow a brute force or a left to right serial method, which is I'll first multiply these two. I'll take the answer of that and multiply it with this. I'll take the answer of that and multiply it with 6. And then I would get the answer from that and multiply it with 7. So let's try and do this. 3 times 4 is 12. 12 times 5 is 60. 60 times 6 is 360. And 360 times 7, how do I go about doing this? 360 can be written as 300 plus 60. And I'm multiplying this by 7. The distributive property of mathematics. So 7 times 3 is 21. So that's 2100. And 7 times 60 is 42. That is 420. Adding both of this, I get 2520. So this is what I would call the brute force method, left to right, being able to do it with a little bit of smart way of splitting the number of 360, the number is 360 and multiplying it with 7. But is there another way? Like if I were to apply the same method here, then it becomes really, really hard because 8 times 9 is 72, 72 times 10 is 720, 720 times 11. Now I've got to start questioning myself and then going into 12. I get out of my comfort of being able to do this, completely in my mind mentally, right? So how do I approach this problem? Is there another way to approach this problem? So let's try and pick that up. Okay, so let's go to the second one and let's start focusing specifically into the second problem, which is what is 8 times 9 times 10 times 11 times 12? So in order to solve this, you've got to start seeing that, the serial method might be too hard here. The brute force method might be too hard. Is there an easier way to do this? Yes. I can club these two together. I can club these two together. And I can keep this separate. In fact, I can think of it algebraically as 10 being x, 9 being x minus 1, and 11 being x plus 1. 8 being x minus 2. And 12 being x plus 2. This is the pattern recognition in math. Now, why is this helpful? Because when I multiply these two, I know the answer is x squared minus 1. And when I multiply these two, I know the answer is x squared minus 4. How is this? Because x plus 2 times x minus 2 is x squared minus 2 squared. A plus b times a minus b is a squared minus b squared. So now I just need to multiply these three terms, x times x squared minus 1 times x squared minus 4. So let's first multiply this. X squared minus 1 times x squared minus 4. Let's use the FOIL method. FOIL stands for first, which is x power 4. Outer, which is minus 4x squared. Inner, which is minus x squared. And last, which is plus 4. This is the FOIL method. First, outer, inner, last. So I can combine these two terms. They're very similar. So in other words, I have x power 4 minus 5x squared plus 4. Now why is this easy? Because now I know that x is nothing but 10. So x power 4 is going to be 10,000. Minus 5x squared is going to be minus 500 from this. And add 4 to it. So 10,000 minus 500 is 9,500 plus 4 is 9,504. And remember, when I do all of this, I need to finally multiply it with x, which means the answer is 95040. As you can imagine, this method of being able to approach it algebraically is much easier than the brute force method that was seen in the previous one. So let's kind of go back to what we were talking, which is what's the approach? Now, as I said, they're similar problems, but I need to look at the difference between them. It's much easier with smaller numbers to apply brute force, and maybe it's quite quick as well to just go about doing this problem. But with larger numbers, it might be a little harder, and figuring out the algebraic connection could be an easier way to do that. That tells you your approach. The ability to solve, right? So it was much easier for me to do algebraic ones, to make it abstract, get it in terms of x power 4, because the reason being x here was 10, which is a round number, and it's much easier to find powers of 10 rather than finding powers of 12 or 13. And therefore my solving ability also worked out much better here. And the fact that it was completely algebraic and I was substituting, the chances of errors became very, very low. So as you can see, being able to decide your approach, being able to decide that approach based on your solving skills and having good solving skills, and also picking up the ones where the error can be minimized, is what I call the fluid math skills. I hope you found this video useful and you are able to apply these fluid math skills in your problem solving. And if you have any stories to share, please update your story in the comment section. Thank you so much.